Hello student, very good morning to all of you. I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the retrosynthetic analysis, and in retrosynthetic analysis we have discussed all the introductory part as well as how it is important and why the university introducing this new topic at T.Y.B.Sc level, and as well as there are the 4 different types of the arrow and their meaning and some of the important terms which are involved in the retrosynthetic analysis that we have learned. And also we have learned so far 2 molecules, how to actually synthesize that molecule, how to do the retrosynthesis and the retrosynthesis as well as actual synthesis in the laboratory. That type of the thing we have seen so far. Let us consider the third molecule. Consider the target molecule. This one. Consider the target molecule. That is TM3. Let us see over here. And now that molecule is this one, target molecule. CH3 CH double bond CH C double bond O and H. This is our target molecule. What do you mean by the target molecule? Once again, the molecule whose synthesis being planned is called as target molecule, right? And what are the things to observe? If you observe this structure carefully, what do you see over here? Here, look at there is a carbonyl group as well as carbon-carbon double bond that is present over there. First, recognize what are the functional group present in the target molecule. Look at here, this is a alpha, this one is a beta, and this alpha beta unsaturated compound or this particular part of the organic compound, the common name of this compound is a chalcone, or it is termed as alpha beta unsaturated compound. How do you obtain or how do you synthesize this alpha beta unsaturated compound in the laboratory? What are the starting material? And as we know that retrosynthetic analysis means what? First part we are generally using first part, that is called as RSA. RSA means what? Retrosynthetic analysis. Retrosynthetic analysis means what? The process of breaking down target molecule into convenient starting material using disconnection and functional group interconversion is known as retrosynthetic analysis. And as I already told you that retrosynthesis means what? Retrosynthesis is an imaginary but logical reverse chemical reaction which help us to reach the reactant starting from the target molecule is known as retrosynthesis. And this is a powerful technique, I can say over here, introduced at a T.Y.B.Sc level so that you can develop your creative imagination, or you can nurture your thinking power, innovative power, imagination power, so that you can design. Once you understood and once you read and understood it, you will be on the way to design your own organic synthesis. That is the purpose, that is the ultimate aim or the goal of that retrosynthetic analysis. Now these are the points you have to write down while analyzing this retrosynthetic analysis, means whatever I have told here, whatever I have mentioned, whatever point here, what you have observing here. First one is a alpha beta unsaturated compound, and this alpha beta unsaturated compound, how we can synthesize this by the Aldol approach. By the dehydration of the aldol, we can obtain such a type of the stable species, which is alpha beta unsaturated compound. The common name of this compound is a crotonaldehyde, and this crotonaldehyde, if you remember chapter number 1, there we have seen one aldol condensation reaction. Condensation means two molecules or more than two molecules condense together. While condensing the molecule, there is a formation of the carbon-carbon bond, and that's why you are synthesizing the new organic compound, and that's why synthetically such type of the things are important as far as organic chemistry is concerned, and therefore this whatever we have talked, you have to mention over here. Now let us see retrosynthetic analysis of this. We have, this is our target molecule 3, right? Now we have shown here, this one I am writing same compound, or let me here generally here I am writing that RSA, retrosynthetic analysis over here. RSA, this is half part. If 3 mark question always appear in the exam, the nature of that question, the nature of the question is like this. Write down the retrosynthesis and the synthesis of the molecule. They will give you there. I already told you that there are near about 5 to 6 molecules are there. So you have to prepare well, you have to study, and as I already told you that practice makes the perfect one, or there is no alternative for the hard working. If you go on studying regularly, if you pay the attention from the beginning, you will be well on the track. So remember here, and here I am showing this arrow. You are familiar, you are quite familiar with this arrow. If you observe this arrow, what this tells us, this is a disconnection arrow, right? And disconnection arrow means what? Disconnection means what? An analytical operation which break a bond and convert a molecule into a convenient starting material is known as a disconnection, and it is one of the important step involved in a retrosynthetic analysis, and therefore this is written, or here you can write as a FGI is written over it. FGI, we know that FGI, full form of FGI, functional group interconversion. And what is it, or what is the meaning of that FGI? The meaning of FGI, one of the functional group is converted into another functional group so that this connection becomes possible. It is that is known as a functional group interconversion, or you can write as alpha beta unsaturated aldehyde, this, or alpha beta unsaturated approach, or the perspective you can use over here. So as usual, alpha beta unsaturated compound is there, and generally the hydroxyl groups are present at beta position. We know that the CH3, then CH, then CH2, then C double bond O, and this is a H. I am putting the hydroxyl group at a beta position. Look at this one is alpha, this one is a beta. When the hydroxyl group present at beta position, that type of the compound, common name is given to that compound is nothing but as aldol. Aldol is a scientist name. First time he discovered or he synthesized that compound, and therefore on honor of this the name of that compound is known as a aldol, and aldol is nothing but as a beta hydroxy aldehyde or the ketone, that type of the organic compound is known as aldol. And that aldol, once you got the aldol, then that aldol means it is just like as a one group disconnection. One group disconnection means one functional group disconnection approach if you use here. And as we know that how the hydroxyl group get broken or how we can break that, we know that. For clarity I am showing that hydrogen atom this way, and now here is a disconnection arrow, that is a Aldol approach, we can call it as Aldol approach. Approach means what? There is perspective. So how it is breaking? This form as a double bond over there, and negative charge present or negative charge resting on this carbon atom. And what do you get over here? CH3, C double bond O and H over here, and now we got CH2 minus charge, C double bond O and H. Now what is this? The negative charge present on that carbon atom, that type of the species we can call it as a nucleophile or we can call it as a base. But nucleophile and the base, as we know that there are the major differences between as a nucleophile and the base, but the nature of that nucleophile as well as base are the have similarity, they correlate to each other. Nucleophile as well as base containing, they are negatively charged species, as well as the heteroatom containing as a lone pair, they are also called as a Lewis bases, or we can call it as a nucleophile, but they are electron rich species or containing the containing the lone pair, generally nitrogen atom, oxygen atom, or this type of the heteroatom containing as a lone pair, and they are forming as a molecule. That molecule you can call it as a Lewis basis, or sometime you can refer as a nucleophile. But the major differences between as a nucleophile and the base, when that base, when it will act as a base or when it will serve as a base, when nucleophile or the negatively charged like species attacking on proton and producing as a neutral molecule, that time we can call it as a that species are bases, Lewis bases are there. When same nucleophile, when attacking to the other carbon atom, specially or often on a carbon atom, forming as a covalent bond, at that moment, at that point, we can say that nucleophile, that species are the nucleophilic in nature, nucleophile in nature, because they are forming as a covalent bond or forming a bond with that carbon atom. Often they are forming as a bond with carbon atom, and therefore we can call it as a nucleophile. And suppose that negatively charged is attacking on that proton and resulting compound obtained as a water, and that type of the species we can call it as a basis generally. So that is the major difference when to call nucleophile and when to call base. Understood this one? This is a major difference. Second major difference between as a nucleophile and the electrophile. In the first semester I already told you that the differences between as a nucleophile and the bases, the bases are controlled by thermodynamic factor, whereas nucleophiles are controlled by kinetic factor. This is the second major difference between the bases and the nucleophile. And third and the last one major difference between the nucleophile and the bases, the nucleophiles are affected by steric effect, but bases do not get affected or does not get affected by the steric effect. So these are the three major differences between electrophile and the nucleophile that you should remember over here. Now whatever discussion we have discuss here. Now this negative charge, now what do you call here, but here specifically in the retrosynthetic analysis, the negatively charged species or negatively or positively charged species, whatever it may be, here we have a special name to special name to them. What is that? Do you remember? Yes. What are those? That species are called as a synthon. Synthon means what? The species which carries positive charge or negative charge, that type of the species are called as a synthon, or what we can call it as a synthons are associated with polarities. After the fragmentation, whatever the charged species are obtained are called as a synthon, and as we know that synthon must have a synthetic equivalent, and now here is a negative charge, we can call it as a synthon, right? Now these synthon has the synthetic equivalent. Every synthon has a synthetic equivalent, and they are represented by this type of the three lines. And now what type of the what atom or what group you are going to attach over here, and generally we can bring, there is a hydrogen atom, we know that hydrogen atom are proton means positively charged, so here you are going to get CH3 C double bond OH acetaldehyde, and this acetaldehyde we can call it as a synthetic equivalent, and that synthetic equivalent can be obtained by using as a reagent like as a sodium ethoxide, right? And sodium ethoxide or any strong base we can use, and by using that one you will get this type of the things are there. This is a synthetic equivalent. Synthetic equivalent means what? While studying as some important definition and term, at that time we have learned with the help of suitable example. The synthetic equivalent means what? The compound carrying a function of synthon is called synthetic equivalent. So this is all about the retrosynthetic analysis. Whatever we have discussed, whatever I have spoken right now, all these things belonging or include in the retrosynthetic analysis. So in this way you have to do the analysis of this molecule. Now the half part is remaining, that is the actual synthesis of this target molecule. And as we know that target molecule means what? The molecule whose synthesis being planned is called as a target molecule. Now let's start as a second part, which is the actual synthesis. Actual synthesis. Now we have just now saw the what? Retrosynthetic analysis, right? And as we know that retrosynthesis means what? An imaginary but logical reverse chemical reaction which help us to reach the reactant starting from the target molecule is known as retrosynthesis. So this is a backward or the reverse process, exactly reverse of that chemical. Now we are starting, let's start the synthesis of that. So now from this you can go from, because we got here is a starting compound, as we know that here the starting compound is a CH. Here you write CH and one hydrogen atom you can write like this, C double bond OH. This is a acetaldehyde, right? Acetaldehyde. This is acetaldehyde, which is the starting material we have obtained after doing the retrosynthetic analysis. Now we are starting from that acetaldehyde. Generally we are using as a strong base, that is a sodium ethoxide, right? Sodium ethoxide, as we know that it is a base, strong base, and we know that its function also, it can abstract the acidic proton. Here look at here, most of the students get confused over here. this is also as a proton, and this carbon atom has a 3 proton. Number of hydrogen atom, we can call it as a proton. But here these are the adjacent carbon atom, they are termed as alpha for aldol condensation reaction. If you remember, we already discussed that aldol condensation reaction in a chapter number 1 with the suitable example. What are the requirement, what are the essential point required to occur or to take place the aldol condensation. First requirement is that it must have a alpha hydrogen atom, then and then the aldol reaction can take place. Number 2, the strong base is used, and number 3, there is a condensation, means there is a formation of the new carbon-carbon bond is formed over there. So that are the some of the essential requirement, or the what we can call it as a criteria for aldol condensation reaction. Here the OET minus for what we can call it as a, here I am writing ETO minus, which will abstract the proton and form as a carbanion over here. And now here I got CH2, C double bond O, and this hydrogen atom now I am putting as a negative charge, because when base subtracting as a proton, why I am altering the word proton? Because it goes with the along with that base, and what the for this bond is nothing but as a sharing of 2 electron, and when proton goes, it leaving its bonding pair on it, and therefore negative charge forming on that carbon atom, and that carbon atom has a special name. What is the special name of this? The carbon atom carrying as a negative charge, that type of the organic species is called as a carbanion, right? This is the carbanion over here, carbanion. And that carbanion, once it is formed, whether they are stabilized or destabilized, there are number of factors which affecting the stability of the carbanion, that we have already learned in our first chapter. The name of that chapter is a carbanion and their reactions. So there 4 factors we have seen. Number 1, the percentage of S character of the carbanion. Number 2, inductive effect. Number 3, resonance effect. Number 4, aromatization. These are the factors which stabilize the carbanion. And now here what is happening here, these negative charges are stabilized due to the resonance effect, because adjacent there is a strong electron withdrawing group, and this negative charge forming double bond over there, and negative charge coming on that carbon atom, and the species obtained. And this is the double headed arrow. I already told you at the beginning their reaction, then symbol and their meaning. What is the meaning of that? This resonance, this double headed arrow, the double headed arrow, the 2 different ways to draw the same delocalized structure. 2 different ways to draw the same delocalized structure, means this negative charge I am showing over here, it is localized, and now I am showing this one. It means that this negative charge not the localized, it is delocalized due to the electron withdrawing group present adjacent to that, and that's why this carbanion gets stabilized, CH2 double bond CO minus, and when that minus charge comes on the higher electronegative element, that species is more stable, and therefore this species has a special name. What is that? We already learned that this species is called as a enolate, and that enolate species is more stable as compared to as a carbanion. So that is the main point you should remember while discussing such type of the synthesis. Now this is a step number first first we have seen step number first. Now let us see as a step number second over here. Step number second, I am taking another molecule, because there one acetaldehyde, another acetaldehyde will be here. Now second acetaldehyde I am representing like this, C double bond O, and one hydrogen atom I am placing like this, so that I can show you the clarity of that mechanism, and that's why I am showing, that's why I am representing this acetaldehyde molecule here like this. And now this CH2 double bond CO minus, that is a enolate species I am writing over here. Now what is going to happen in the second step? This negative charge coming down, forming as a double bond between this carbon atom and this oxygen atom. Now this double bond attacking on that carbonyl group, and negative charge on the more electronegative atom, which is oxygen atom. Oxygen atom is more electronegative than carbon atom, and therefore negative charge on that oxygen atom, and then here forming CH2 and then C double bond OH, right? This is the alkoxide type of the intermediate you got over here. Now I am roughing this blackboard, or let me clean this blackboard over here so that you can clearly see the rest of the thing. Now in the step number third, what I am doing over there, step number third, I am taking this molecule as it is over here. Look at here, CS3 CO minus, then CH2 C double bond O and H. Now adding H2O in presence of H plus. This process is called as a protonation. Protonation means what? This alkoxide will pick up the proton from solvent, and the compound form is known as aldol CH, then OH, this CH2 C double bond O and H, right? And this is a alpha and beta. At beta position there is a hydroxy group, and therefore it is called as a aldol, right? And as we know that aldols are very unstable, and now when this is the first step we already seen, step number fourth over here, fourth we can show. Now I am writing that molecule as it is over here, CS3 then CH OH. I am writing here the two hydrogen atom. One of the hydrogen atom I am placing downside C double bond O and H. They are as it is, and just hitting it. That triangle indicates as a heating, and after the heating it loses the hydrogen atom. This hydrogen atom in this way, and OH from here there is a elimination of water molecule. This process is known as a dehydration, and the product which we are going to get over here, CS3 then CH double bond CH and C double bond OH, and this is nothing but your target molecule 3, right? This is your TM, means target molecule 3, and which is known as alpha beta unsaturated compound, alpha beta unsaturated aldehyde here, and the common name of this compound is a crotonaldehyde. So in this way you how to do retrosynthesis and the actual synthesis. Once you are able to do the retrosynthesis, it's a very important one as far as your organic chemistry is concerned. Once you do the retro, then it is very easy to synthesize by indicating as a proper reagent and the reaction condition. You will arrive at the final product by using as a proper suitable reagent and the maintaining as a proper reaction condition. So in this way you can synthesize, you can prepare, you can do the retrosynthesis, whatever named reaction or whatever oxidizing reagent, whatever reducing reagent, whatever named reaction you have learned, all these you have to keep in mind, and accordingly you have to go backward so that you can disconnect, you can break the bond in a such way that, but before breaking that bond you must know how to make that bond. So don't break the bond randomly. First you must know the reason, you must know the how you can make that bond. Once you know, once you click in your mind, then and then you can break that bond, so that you can prepare, you can make that bond easily. So that way you have to think, because this chapter is mainly focusing on the imaginary power. You have to think in such a way that you have to break the bond in such a way that you can make it easily with the greatest simplification as well as with the good mechanism. Mechanism, as we know that mechanism means what? A detailed study of sequence of steps which are involved in the conversion of reactant into product is known as a mechanism. And in organic chemistry, mechanism is nothing but as a language of organic chemistry. And as I already told you that if you know the language, you can express your feeling or you can convey your message to the person whom you are going to express that thought. So I think let us stop today here. Remaining we will see in the next time. Thank you. Have a nice day.